We have reached the point where we are going to scan the part. There are some precautions you should take regarding the part and its preparation before starting the scanning process. In other words, some parts are more suitable for scanning than others. Proper preparation is necessary, and in this regard, certain precautions must be taken. I will outline some situations that I believe are probably the most important. The first is the geometry of the part. A part with poorly defined geometric elements, or one with uniform panels lacking significant detail, will be more challenging to scan because the scanner struggles to find reference points to relate the points to each other. In most cases, extra assistance is required to scan such parts. The solution can be as simple as creating random points on the surface of the part, provided it is feasible. There are adhesive markers available that can be removed after the scanning process is complete. Another situation, which also depends on the scanner and the type of technology being used, involves shadow areas. Some scanners do not handle this well, so the lighting of the part should be as uniform as possible. Next, there is the issue of surface finish. In this case, it's easy to identify ideal parts for scanning, those with a matte surface finish, as they lack shine and therefore have low reflection levels. The worst scenario for a scanner is a dark surface with a high reflection index, as this will undoubtedly cause scanning issues. However, it is possible to scan parts with these characteristics if prior preparation is done, such as making the finish matte. There are aerosols available on the market that achieve this, and the effect disappears after a few hours without damaging the part. Another issue that causes problems is transparent parts. Transparent parts are often also highly reflective. Although there are anti-reflective treatments available, the fact that they are translucent means the scanner will still struggle to visualize them correctly. An example would be eyeglass lenses with anti-reflective treatment. In these cases, once again, it is necessary to treat the part, such as applying an aerosol. Surfaces with repetitive patterns also present a challenge for scanners, particularly if the scanning relies on texture-based alignment rather than the shape of the part. However, in this analysis, we are interested in obtaining the geometry to extract the dimensions of the part being analysed, so this issue does not arise in this case. There is, however, another situation that comes to mind. Imagine the part is not rigid. When you place it on the table, it begins to deform. This is obviously a problem, as the part will continuously change shape and the scan will not turn out correctly. Thus, it is indeed not easy to scan flexible parts. In such cases, it is ideal to take single captures one frame at a time so that the capture is done quickly. Otherwise, the generated model will be a fusion of all the moments the part deforms, which will not be representative of reality. This issue is especially critical during prolonged scanning sessions. Another critical aspect which may cause some confusion and lead to criticism or the perception that the device is of inferior quality relates to the size of the part. There are scanners that are suitable for scanning large parts and others designed for small parts, capable of capturing minute details thanks to their high resolution. However, in this case, the Vega seems to aim at covering both ranges with its two available systems, MEMS and VT-Cell. Nevertheless, these systems have limitations, as is natural. If I attempt to scan a coin with this scanner, as I will shortly, I know I will not obtain a detailed representation of the coin based on the resolution this scanner allows in HD mode, which I believe is incorrectly stated on the Einstar website. In conclusion, this scanner is more suited for slightly larger parts, which is perfectly normal and should be something that brands clearly communicate to avoid returns. It is very easy to create high expectations when the limits of what the scanner can do are not understood. It's almost like trying to observe a planet such as Jupiter with binoculars. Although it is the largest known planet in our solar system due to its distance, it will still appear small and mostly lacking in detail through binoculars. This is because binoculars are not the appropriate tool for observing such a distant celestial body. In this case, a different type of instrument is needed, a powerful telescope with a high-quality optical system to view the planet. A large optical magnification alone is not sufficient. There are other characteristics in the lenses and construction of the telescope that allow for detailed visualization of the planet. But it is certainly not binoculars, which are designed for viewing objects at relatively short distances. This same situation applies to scanners. We cannot say, these binoculars are not good because I can't see Jupiter, or question whether the instrument being used is suitable for the task. Similarly, the quality of the components used plays a role, just as it does with telescopes. In a scanner, high resolution does not guarantee precision and accuracy, a topic I've addressed in a previous video. Sometimes analyses and criticisms emerge that suggest the device is weak, but in reality, the expectation created was far too high. Every device has a range of applications for which it was designed, and naturally, performance outside that range will be inferior. Thus, if you often work with very small objects, you should look for a scanner that is more oriented toward that segment. Conversely, there are scanners designed for large objects. In short, the size and scale of the object are also important considerations when evaluating the conditions necessary for scanning. For small objects, you will need to move around them or use a turntable similar to the one shown. It is also essential to ensure that the object is stable and does not fall during scanning. Otherwise, you will have to start over. For large objects, you may need to walk around them while scanning, so plan for this before starting. In such cases, while scanning, try to move as if you were painting with a spray gun. This applies to both the speed and trajectory of your movements. The term used is not painting, but sweeping, at least in Portuguese, and it should be as uniform as possible, without skipping areas. For example, when scanning people, you should always start with the face and not return to that area. Why, you might ask? The reason is the eyes, or more specifically, the eyelids, which are constantly moving. And again, we are dealing with an object that moves. When scanning people, you cannot prevent blinking or ensure the person remains perfectly still like a statue, but it helps if they stay as still as possible. However, there are physiological movements such as blinking that cannot be controlled. This is why it's best to start with the face and not revisit that area later. Another point to highlight, which I've touched on before, is proper lighting. Remember that you are using a device whose sensors rely on optical systems, including lenses. Interference from light can disrupt point capture. For example, flickering lights or those with certain frequencies can create intermittent shadows and other undesirable effects that should be avoided. A clean environment, free from large amounts of airborne particles that might interfere with scanning, is also important. However, particles like dust usually do not cause issues due to their small size. But consider scanning in a carpentry workshop. Such environments typically have significant dust levels that could interfere with the process. Additionally, over time, dust can settle on the front of the camera, potentially causing problems as it obscures critical areas like the MMs or VXL sensor. Interestingly, despite the IP50 certification of this model, when I received my unit, I found a considerable amount of dust inside the sensor area. Whether this affects the unit's performance remains to be seen. These details, while obvious, can sometimes go unnoticed. Results may fall short of expectations if, for instance, during a session with a distant client, you didn't realize the sensors were covered in dust. I believe this covers most of the situations that can complicate capturing an object's shape. There are others, but I've focused on cases where the goal is to capture the shape and dimensions of an object. For capturing textures, there are additional considerations, but in summary, you should take the same care as you would when taking a good photograph, with the added requirement that the entire object must be properly illuminated to capture all the model's nuances.